Hello and welcome to this simulation. Today I'm going to do a model of a blast explosion over the steel tank contain soil. This paper presents this figure present a simulation, and the right bottom for this figure you can see these are the rebars, and this is the thin layer of a, I think it is polymer, I think, and instead that and in this filled with soil. You can see that. So the paper, this is the schematic, but I'm going to use a steel tank instead the uh, beam. You can see here and here it is. And you can see this is the result. This is all the result. Okay. So that's me to create something like that, but by a steel tank. So first I create the steel, name is shell, a steel tank, the 3D deformable shell and extrusion approximately 3 meter. Okay, continue. So create a rectangle, the first point minus half, press enter, again minus half. This is our tank, press down double, and 3 meter is a depth. And I want to close here. Here is open. So I use shape, shell, sweep, edge. This is, select this edge, press done. The direction is okay, or you can change it, flip it. Okay, and the profile is this now. So this profile extrude along this direction, press done, and okay, and you can see it is closed now. And the other point is soil. I'm going to use Eulerian model uh, for the soil displacement or soil uh, movement in the Eulerian domain. But the explosion way, I use Conwell. I can use Eulerian explosion, but here I prefer to use the Conwell. So the soil 3D deformable solid extrusion approximately 3 is okay. Again, create a rectangle, minus 0.5, minus 0.5, this is the first point. 0.5 and 0.5, this is the second point. And press done. And the depth is 3 meter. Okay. Now the Eulerian part, the Eulerian domain. The Eulerian domain is Eulerian and 10 meter approximate size. Extrude solid, continue. And it will be minus 2, minus 2, 2 and 2. This is 4 meter size for the square, press down, and the depth is 6 meter. This is the Eulerian domain. So let me do enter the material from my library. You can use the paper or anything which you have for the material. This is a steel and this is soil. Let me to check them. Soil, the density 1800 kilogram per meter cube. Here this is the density. The elasticity 20 megapascal, Poisson ratio 0.3. And for the plasticity, I use more column plasticity. You can use cap plasticity, clay plasticity, and this is the more column plasticity. So the friction angle 10, dilation angle 0.1. You can change them, these are arbitrary. And cohesion 24 24 kilopascal, absolute plastic strength is 0. This is soil. And for the steel material, I use this in the documentation, this reference, example manual, the dynamic stress, eroding. I use this. This is the reference for the material. Okay, let's me to check it. Steel, ductile damage criterion, you can see, I use that. You can remove them and just use plasticity, but it is better to use them. Maybe the amount of TNT would be a large amount, or for instance around 500 kilograms of the tank experienced the damage. So I use ductile damage. It has three criteria. It's three components: fracture stress axiality, triaxiality, and a strength rate. And I use damage evolution. The damage evolution depends on the last plastic strength point and the mesh size. The energy depends on that, and it's 500 joule exponential for. And you can find it here. This is the ductile damage. And the other thing is the shear damage. Shear damage again like that. This is the parameter for steel, and the damage evolution again. And the density, elasticity, 200 gigapascal, Poisson ratio 0.3, and plasticity. The plasticity dependent on a rate because of the rapid deformation. You can see these are the data. First done. I now create the Eulerian part. Type Eulerian, continue, material, just select the soil and select the assign section and done. Now it is completely soil, but by using volume fraction method in the load, we can define the initial location of the soil, and the other area or other zone will be void. And for the shell, I create the steel shell, homogeneous. The thickness, for instance, 2 millimeter, and the material is still done. And I assign to this part to all. I use bottom surface because I need the extra direction outward the tank, no, inward. See that? The view, part, render shell 10, and you can see these are the base surface has interaction with soil, and that is okay. The extra direction is outside. So that is okay. And now in assembly, enter all part. This is the all part. Okay. Use this option. And now move this part done. That's the first point 0. The second point, zeta direction. It will be minus, for instance, 1 meter, minus 1 meter, and that's okay. I now create 2 points, the atom points, offset point from this point. From this point along zeta direction, 2 meter, and from this point along y direction, yeah, y direction, yeah. It will be 1.5. Okay, that is the point on the tank. So assign 2 reference points, first to this, second to this. Okay. We need them for the start point, standoff point. This is the detonation point, and this is the standoff point. And now create dynamic explicit step. Continue. The time for instance 0.06. You can increase that. It will be better if you increase that. And the output, let's meter equals 100 interval, and failure, I use damage criterion. A state, it will be status, and density for the Eulerian, and status for the Lagrangian element. If we have failed element in visualization, by this case, the abacus remove them from the viewport. Okay, and now the interaction. We don't know anything about the interaction between soil because the soil is Eulerian and the tank is Lagrangian. So I use a default property, contact, and this is default. And I create the initial general contact, the contact between all domain, and that is okay now, press done. And I create another thing is a blast property. The blast property should be incident wave, continue. And the definition is a blast and 200 kilogram TNT. I use 200 kilogram TNT. So that's what you use in step 1, below, sorry for that, incident wave. This is the source point, the standard off point, and here I select the shell. Okay, this is the surface ground. The type is convex, time duration 0, and the magnitude is 1. Okay, and this is the definition of the blast load over this. So, the boundary, again, lets me to replace the shell. The boundary in step initial will be in cancel for this line or these 2 points, cancel. And for this bottom surface will be velocity 0 in all the direction. Other direction will be free, and so it can move through them. Okay. Before defining the volume fraction, go to mesh module. The mesh module Eulerian, I use 0.1. Okay, mesh it. If you can, use a smaller mesh size. Explicit linear Eulerian, and the element type is this. Okay. This shell 5 centimeter. Mesh it. It is a good mesh. And the element type will be explicit. Shell element dilation, yes. This soil will be again 5 centimeter. Mesh it. Explicit and okay. And now go back here. Create a discrete field volume fraction. This is the source part, and this is our volume. You can see here, this is the volume which filled with soil inside the Eulerian domain, and it is high accuracy, and press done. Okay, and now here, other material assignment, continue, select Eulerian part, discrete field, and now the material soil assigned to this location, and the other zone will be void, can soil go through it. Okay, and done. And we don't need soil more, suppress it. And now create a job, name it job 1, continue, done. Okay, submit it. Already I did this simulation, and now just I will check it for the possibility, or I use a bigger Eulerian domain here with a smaller mesh. Already I did it with bigger mesh, and we can check it for the result. So you can see it is okay now, just it for 10 minutes to be complete, so I kill it and I save it for you. As a model 2, already I did model 1. So let me to enter model 1. The model 1 is this. See the mesh is bigger. See that the mesh size is bigger. And the job result, it will be feature edge. The threshold is 100. Let's use height. If I click on this, you can see the deformation and collapsing of the I use that for instance, and the stress. See that the deformation and the collapsing of a steel tank. If we use a bigger domain and bigger time, it is completely collapsed. So this is the tank. So where is the soil? Let me do this. This is the soil. You can see it is go through the tank. See that? This is soil. See that? Okay, or we can use that, it is better with mesh. See that it is soil. See, that is soil. Okay, if I use this option and I use feature edge and soil volume, see that this is the first position inside the tank, and that is okay. And then after the blast, you can see that the formation of a tank and the soil inside the void domain. See that? Or the density. This is the soil density. The soil density increases. See that? Because it is compacted. Or soil plastic strand. Let's me to use this. See the soil plastic strand. See that? Or let's me to remove this part and see the soil. Okay, and let's me to hold this. Before that, let's me to replace stress. Okay, and this is the tank and the ductile damage. This is ductile damage happened here and here. Sorry, shear damage, you can see them. Displacement, see the displacement. Okay, that is the simulation, and if I request pressure for the soil, you can see the amount of the pressure which soil experienced because of the tank impact. Okay, there is nothing to do, and this is all the simulation. You can change everything based on the video. Thank you for attention.